How's it going, everybody? And welcome to another installment of YouTube's AMA. So I wanted to cover some more questions that were posted and try to get you guys some answers and all that good stuff that goes along with it. So I'll cover this video. There's a couple other ones that I want to work on too, but before I actually answer the questions, I want to give everybody kind of a quick update of where I am at with other stuff. So we have I'm a little apprehensive to show you this, but because it's a work in progress. It's not the lockdown, this is the for sure thing I'm going with, but it's like really close. So this is the topology I am looking at going with for the ENARSI exam. And you're probably going, holy crap, it's pretty big. Yeah, it is large, but intentional, because the request that came through was, can you make a topology slash lab that is big enough that will cover all the ENARSI topics? And this one definitely covers all of that. So the driver behind the size is because we need BGP, we need IGP, we need MPLS, we need DMVPN, all that type of stuff. So I still haven't broken it all down yet, and it's still a work in progress, but this is essentially the topology I've come up with. These are all iOS V routers, so they take a very little amount of resources to run with. And so, you have your HQ location here, you have your two medium sites here and here, then you have your MPLS VPN down here, then you have your two ISPs, ISP1 and ISP2, and then you have your spoke sites, spoke 1, 2, 3, 4, 5. Then you have a couple of CE sites that have devices attached to them. And then we have a colo here in the middle that connects to both the internet and to MPLS. So that if you've got users coming in from home, they would be able to connect in, or whatever the case might be. I might even have just a home user that I attach, just to make it easy to follow. But the bottom line here is I have a little legend up here of what the devices are. But the idea here is to have it labeled in such a way that if you're working towards your CCNP, I'm assuming you're coming from a CCNA and you're knowledgeable, but you're still working on building your technical depth. So as I was thinking about it, I was like, okay, when I took a look at the CCNP and ENARSI topics, so let me jump over there real quick, just so that I have a visual in front of you guys. Oh, that's right, I had to scroll. They changed up the website just a little bit. It used to be very, very easy to find. So if we look at ENARSI real quick, and we look at how this comes out to play, the key thing is layer 3, right? So the key thing is layer 3. There's a big piece of that. A third of the exam is going to talk about, EIGRP, OSPF, BGP. There's troubleshooting on that. But if I bring over the Encore exam topics, there's compare EIGRP and OSPF, but they really only have you configure OSPF and eBGP. So as I was looking at that, I was like, oh, okay, well, my thought process was like, okay, maybe it would make more sense, considering the way that the exam topics are laid out, to layer Encore topics and ENARSI topics together at the same time. So what I mean by that is actually very straightforward. So we would have, for example, when we take a look at the Encore exam for configure simple OSPF v2, v3 environments, including multiple normal areas, summarization, and filtering, well, I could simply create, that could be one big OSPF environment, or another OSPF, set up here where it's all area 0. And then we can do the same thing. We can build upon the topologies and break them down and layer it in so that we're covering both Encore and ENARSI topics at the exact same time. So it's covering both. Now, I even thought, well, maybe I should do like a CCNA level. And when I looked at the amount of configure versus describe, which is configure versus understand the theory, there's a lot more theory on the CCNA than there is in CCNP, and rightfully so. So what I said, or what I thought, is I was like, instead of going through and doing a workbook dedicated to CCNA, which there's already official certification guides and things like that, most people, and especially when you look at, let me look at exams and training. Can I go back one? Certifications. When we look at CCNA, for example, and I had this open a little bit ago, that's why. So we look at exams and training, and we look at the exam details, and we look at the exam topics. You'll see that we have a whole section dedicated to fundamentals, which I already covered on my YouTube channel. So if you want to go through that, be my guest. Then you have network access, which is some basic VLAN configuration. I was like, okay, well, I plan on covering that. So I plan on going through a full breakdown, implementing all of those capabilities. So we would already be covering CCNA as it is. So instead of calling it the CCNA Encore and ENARSI workbook, it would be just CCNP, Encore, and ENARSI. Now, I'm already certified in both Encore and ENARSI, so to me, it only, like, I can quote it that way. So because it's going to be exam specific, we're not going to be talking to Cisco Enterprise Series where we cover everything from CCNA, or at least cover every topic that's on the CCIE blueprint, which is one topology. This is going to be a topology in the size that you would need if you were to look at all the different things and all the different topics. This is what this is the topology. If I was going to develop one, this is pretty much what I would build out. If you want to test out everything so you can see it end to end, it looks very similar to what I did for Enterprise, because at the end of the day, a lot of the same topics are there. The only difference is we have a single hub instead of multiple hubs. Now, I am planning on doing 2 clouds, so you guys can see what it looks like to do one over the internet and then one over MPLS, and then how we can steer traffic to one over the other depending on, maybe an SLA, quality of service, that type of stuff. So I looked at the exam topics for CCNA. I was like, okay, well, I'm going to be covering that already. IP connectivity, I'm going to be doing a basic OSPF design anyway. And if you get into services, we're going to be covering NAT and NTP and DHCP. So all those same topics are on ENARSI. So it's like, well, I'm going to be building a workbook that's going to be geared to that. Now, I also looked at like a video aspect of this, and I haven't found a good place or way to do the video series. So like for example, not doing it on YouTube. And so I decide I'm more heavily leaning towards, a lot of folks already know about Patreon for the workbook, so I'm planning on keeping that paradigm in place. So this workbook would be, I'm going to incorporate both Encore topics for routing and switching that are configuration based, and that have anything that's like describe something that might be relevant. We'll cover the 2-tier and 3-tier hierarchy. We'll cover a little bit of fabric. We'll do a little bit of cloud redundancy, first hop redundancy, that type of stuff. Multiple devices, first hop redundancy, HSRP, VRP, that type of stuff. Staple switchover, stuff like that. I'm staying away from wireless, SD-WAN, and SDA. Those are going to be topics you'll have to study on your own. And we'll talk a little bit about QoS and how you can implement QoS to do some stuff. But for the most part, we're going to be covering the main pieces of the exam, which I'd say, if I had to balance this out, I'd say probably 50% of the exam is configure. I'd have to go through and really break it down. But there's a lot of configure in the exam. There's enough in here to make it worth the effort to do an Encore piece. Now, I'm not going to break it down into Encore specific tasks and then an ENARSI. It'll be encompassing both because there's so much overlap, right? That's what makes sense. That's why I decided not to do anything for CCNA, because the amount of topics that we would cover, configure static routing, configure OSPF, configure layer 2 discovery protocols, layer 3 and layer 2 LACP and ether channels, VLANs and trunking, NTP, NAT, DHCP, things like that. Remote device access using SSH. So a lot of these, anything that's really configure, they're going to be covered anyway. Describe IPsec remote access and site-to-site VPNs. Well, I'm going to do a site-to-site VPN and then a GRE, then a GRE over IPsec, so you guys can see how that comes into play and the differences between a policy-based VPN versus a route-based VPN and how that would come into play. Now, I'm not specifically going to call them out, but as CCNA topics, but they're going to be there in case somebody that's got their CCNA and wants to move into Encore and ENARSI, the groundwork is already going to be laid. That is the point that I'm trying to convey, is that it'll be covered. And the topology will be encompassing this. And the topology that I'm working towards will include, it'll be broken up into two major sections. The first section will be all deploying. So we'll be taking all of these different topics that are troubleshoot, anything that's a troubleshoot topic, we will implement, and there will be a lab specific for it. And then we will then circle back, and then I will build out, I don't know, maybe it's 25, 30, 35, 40. It depends on, as I'm going through all the different variables, how we would troubleshoot them. And so it'll be, some will be dependent on others. Maybe something won't work until something is put into play. But that's really, if you want to get to the expert level or be a much stronger engineer or really a rock solid NP, then these are the things that you're going to have to do. You're going to have to know how to troubleshoot every layer of the network, and that's really how you become that expert. It's not by, watching videos over and over and over again. It's, once you learn the fundamentals and all the different variables of the protocol, any switch or nerd knob you can turn, twist, pop, or flip. As you go through all of those, that's what really makes you the expert, right? So, and that becomes very evident very, very quickly. So the cool thing about it is once you get into the details and you start breaking all this stuff down, we'll talk about MPLS. We'll deploy DMVPN. We will look at unicast reverse path forwarding and dealing with AAA with local database. I don't have a AAA server. I could deploy ICE and get that working for TACACS. Maybe I do. And maybe I implement it for a couple of devices. I don't know yet. And then infrastructure services, we'll definitely look at DHCP. We'll look at NAT, NTP, NetFlow. Maybe I download PRTG and we can pull out a demo device and just see what it would look like. So that there are options available to us. And the topology is built specifically for us to dive into those things. So it's going to cover Encore and ENARSI topics and be specific to the technologies that are listed on that to try to help you guys work through them, and with the intent of being stronger engineers, right? That's the whole point that we want to make and how we would go about doing that. So I haven't actually started writing the book yet. I'm still developing the topology that we're going to be leveraging. So that's the other thing. So this workbook will be done exactly the same way I did Enterprise. It'll eventually be a Patreon. It'll be $50. That's a number I've already picked in my head. It seems like a fair price across the board. But I am also working on trying to figure out how I can do a subscription where any videos that I create for any of the content that's going on will be available through Patreon. Instead of me going out and creating a website and all that type of stuff, I'm looking at creating dedicated, like a membership level, I don't know, like $25 a month, something like that, to where you can subscribe or become a member of it for, it's a little bit more than the YouTube membership, but it would include the live. If you did that, the $25 a month, that's the price point I have in my head. That would give you access to any videos that are specific to the workbooks, which is the direction I'm probably going to go with videos in the long run, is any videos that I create that are going to be a companion to the workbooks. Then you'll also get, if you don't care about the videos, you just want the workbook, then the workbook will be its own price point. Where if you want the videos and the workbooks and access to the membership of the YouTube channel, all that type of stuff, it'll be one flat price across the board. You'll get access to everything. So that is my goal, and then it'll be anything that's specific to Workbook. That those videos will be available for membership through Patreon, and we'll work through getting all that squared away. So my goal, and I haven't figured out how to make this happen yet. Like for example, if you already have the enterprise workbook, and then you say you want to become a member of Patreon through Patreon for the Encore book and the ENARSI book, and then any videos that go along with that. And I'm planning on doing a video series for the enterprise workbook as well. So that'll be coming at another point in time. But I haven't figured out how to do it. But if you bought a book, but you also want to be a member, then my goal is to mesh the two, so that if you get the membership, then you get access to all the workbooks and the videos that go along with it. It'll be like an all-access pass. So I have to figure that out yet. Maybe it's going to be really, really simple, and I'm probably overthinking it, but I have some ideas in the back of my head on how to make that. So that's kind of the direction I want to go with it, so that if people are actually interested in diving into that and they want to ask questions and things like that, they'll be able to do those things and all the good stuff that goes along with that. So just be patient. I'm working on through some stuff to get that, make that a reality. So with all that being said, let me go ahead and jump back over here to our comments and our mentions, and we'll start to answer some of the questions that we have here. So can you give us a detailed explanation about Cisco IOS types? In which Cisco hardwares do we find them? Where do we apply them in enterprise network infrastructure? Good question. So IOS XE. IOS XE is the successor to iOS, which was the Internet Network Operating System, which is what iOS stands for. And iOS XE is a different architecture, which is supposed to be better than what iOS did. So iOS was very monolithic, where if something happened in the kernel, the whole box would crash, where iOS XE is supposed to be more of a distributed. It's supposed to be like a Linux daemon, is how you break it down. So XE is the successor and has way more functionality. So you can run containers and other things on top of your router if you wanted to do that. It's pretty cool what you can do. iOS XE is going to be found in any of your modern Catalyst platforms, your ASR platform, which is being replaced by the Cat 8K, the Cat 9K, things like that. The new wireless controllers are XE based, and then your SD-WAN stuff is going to be available that way as well. Your iOS XE SD-WAN, stuff like that. So that's where that would come into play. iOS XR is a service provider platform that runs on the ASR 9K, the NCS platform, some of the ASR 300 or the 3-digit, the 920, the 902, I think, the 900 series routers. It's very rare to see this deployed inside of a customer. This is going to be something you would see inside of a service provider. So it is similar to Juniper in a lot of ways. But if you want to study service provider, you're going to have to know XR. And XR has a healthy installment of segment routing. So you'll get a healthy dose of that if you want to dive into it. iOS, drop the iOS for NXOS because Nexus and iOS are two different operating systems. And so Nexus is the data center switch. So that's what you're going to find if you want to run VXLAN, EVPN, data center switching, like for storage, things like that. Nexus 9K is the platform that's out there today. It does support a lot of capabilities. So I actually did a deep dive on VXLAN a while back. So if you want to dive into that, be my guest. iOS V is the virtual router, which is what this is right here. If I was to right click here and say edit, it's running iOS V, and not that, cancel, edit. Here's the router. So I'm running 15.6 code currently, but this is the version of code you get from CML. So that's where that comes from. There's no hidden secret of where I get my stuff from. So that's where that comes from. So that's that. And then IOU is iOS on Unix, which is how and that just became available. Cisco for a long time had that, kept that really close to the chest. So that's where that comes into play. So if you want to do iOS, that's essentially what the exams are going to be testing on, is iOS. Eventually they will move away and they'll get into XE, and eventually iOS will just kind of die off. So good to know about contiguous and non-contiguous addresses. No worries. So I am working on, I'm going to rebuild my BGP multicast, BGP and multicast lab that I have. There's some issues that I'm seeing with it as I'm starting to dig into it a little bit more that I need to remove and make it more real world. So there's that. So let's see here. For those of you that are studying for your exams, one thing that I definitely recommend everybody do is for what like what I did for the VMware VCIX exam, and I'll give you just a quick example of what that looks like. I created a spreadsheet that laid out all the topics on the blueprint, which basically is how I guarantee exam success. Is if you go through all the different topics in the blueprint and you detail them all out, you read up on them, you took notes on them, then you tested it out if it was possible, so that when you go to sit for the exam, you're not surprised by anything. So, or at least to the best of your ability. That's what I did. So if you're looking to do that, I definitely think it's a good idea to take the exam topics, lay them out so you understand how they all work and the details behind them. I'll do my best in the workbooks to give some basic explanation as to what it is, how it works, give a before and after snapshot of what it looks like on the CLI, and go from there. So yes, I'm glad you, can you talk more about the time estimation you give yourself planning-wise for every topic? Like you set a time frame to study a certain technology on the spreadsheet or not? And the answer to that question is actually pretty straightforward. I don't set a time frame, I just study until I understand it. So if I can pick up on a topic, it's a lot of times it's really easy to understand how a topic works at a high level, but it's when you start getting into the weeds of all the different things that you can do with it that it becomes more complicated. So I try to keep things very simple when I start off and then build on that. And I will, if I'm running into, I'm running into an issue trying to understand something or something isn't working, that's when I start looking at, okay, what am I missing, not doing correctly, or whatever the case might be. And that's how I would move forward with that. Good idea about the workbook and the E topology for ENARSI. Can you please use ISVL3? Yes, I can. That's what I'm doing. IOL. I don't need a powerful CPU. I'm not forgetting about real-life networking course, but the problem with the real-life networking course is the fact that it's very fluid. And somebody made a comment about how, where was it? And it was actually a very good comment. Now, I think it was further down. Maybe not. Yeah, right here. This comment right here. Right above it, actually. Said, I'd be very interested in an ENARSI workbook that I can follow along on what to configure so I set up my own topology. There was another comment in here. I forget where I saw it. But essentially, the comment was to the effect that they think it's a good idea and whatnot, but you would have to come up with defined topics to cover so it would be easy to follow along with. And I completely agree with you. If I was given a huge topology and somebody was just like, okay, here's what we're going to go do, there would have to be, you'd have to do some sort of curriculum, if you will, or an agenda that you're going to cover. So I do plan on doing that, but real life really needs a breakdown as to what I'm going to cover and where. And there's actually some stuff on there that I don't know how to do off the top of my head that I plan on going through. So it would be a kind of a real world, I think, like a workbook that transitions into a video series that we'd be able to walk you through and stuff like that. But we'll figure that out. Let's see here. Be here. Yep, got that. You'd be interested in the ENARSI workbook as well. Good. Also, how much of a topic is enough? When you lab the topics required in a Cisco curriculum and study everything on the Cisco cert book, now is it enough or what? So that's one of those things where when you start getting into the weeds, it's one of those things where it's very, very easy to overstudy and to overwhelm yourself. I'm facing that same thing right now where I'm actually taking a break from my service provider studies to focus on other things that I know forefront. And I'm planning on doing a service provider set of workbooks as well. And the purpose behind that is multi-purpose. One, it would allow me to go through a CCNP service provider more thoroughly. I create the workbook and I start working through the configs, making sure I can get everything working and all that type of stuff. That's kind of the main driver for that. So if you can get through those details, the better off you're going to be. So here's the thing. If let's say you're studying for Encore. So you've got a CCNA and you're studying for Encore. And let's say you've covered all these different topics, which is why I think that the spreadsheet's a really good idea. If you have gone through all these things and you know how to do them, whether you can configure them or not, but you know what they are, you know what WebAuth is, you know what EAP-OL, Extensible Authentication Protocol over LAN, it's a four-way handshake. If you can do these things, like I know just about every term on this page via an acronym, so that's really where it comes down to. If you know all the different nerd knobs and what they do and how they work, then anything that is a describe, you should be able to very easily go and answer the questions on that. That's my take on it. So if you read the configuration guides for how to configure TrustSec and MaxSec and what next generation firewalls are, you should be able to read a question on an exam and be able to eliminate one or two questions. I'm not saying that's foolproof, but it's going to give you much better odds than if you were to just go, I don't think I really need to study that. Well, then you're setting yourself up for failure. So the whole goal here is to make sure that you understand how all these different things work. And if you understand how they work, then you're that much better off long term. So that's where that piece comes into play. So my opinion is if you have covered all the topics on the exam blueprint as thoroughly as you possibly can, and you try not to do what they call paralysis through analysis, so you don't sit there and go, well, what if they cover this topic, or what if they cover that topic? Well, for everything you say, what if they do this, what if they do that, then that's just another thing that you need to cover. You can cover it as thoroughly as you want to. I know when I was studying for my CCNP, I was going through CCIE deep dives because I had no clue how far they were going to go with it. But I wanted to guarantee exam success. Guess what? I still failed. Why? Because I just needed more time to absorb the material. I was going through it too fast. So you go through it as thoroughly as you can when you're doing it. That's how you do that. So, and sometimes you get to a certain point where it's just like you have to, as my dad used to say, either crap or get off the pot. Like, how much time are you actually going to sit there and worry about this? Maybe it's time to just pull the trigger, schedule the test, and go take it and see how you do. So, because you don't know what they're going to test you on until you actually get there. Is there a practical workbook that's recommended for CCNP and ENARSI? I'm actually writing it. So, now for Encore. So, I will be walking you guys through all the different labs for that, as I've already said. So, that is my intention to do. I'm hoping that it'll be out probably sometime... time frame wise, maybe sometime summertime. I'll be working on it for a little while every night until I get it done. And the last question before we, maybe I want to hold off, but so if I understand this correctly, please excuse me if I don't. The reason IS to IS and IBGP are used in the provider core is IBGP is used to avoid redistribution on the eBGP PEs, correct? Because if it was just IS, the PEs would have to distribute all that in the ISP core, which would result in high CPU utilization and resource usage, correct? Because why else would you utilize two IGPs in one AS ISP core? You're not wrong, and you're mostly correct. So again, it depends on what you're attempting to do. So for example, if you're dealing with internet, so specifically for internet connectivity, so your internet transport, then you're going to be using a IGP for reachability, because that's the first key thing. If all of your devices, if all of the routers running BGP aren't going to be wired directly to each other, but they're going to be wired in either a ring or in a very loose mesh, maybe like a data center fabric spine leaf type of design, then you need to have some way of interconnecting them together. So iBGP and typically route reflection is going to be used in order to do that. You need IGP to do propagation of the point-to-point transit links, the /31s or the /30s, as well as the loopback addresses on the devices so that they can form iBGP route reflected peerings with each other. And that's going to be how that'll come into play. So if you don't do that, then you have to meet the iBGP full mesh requirement. And that's the key thing that I think you need to remember is if you're dealing, so maybe you're having a hard time understanding, maybe you're blurring the lines heavily between traditional campus LAN or data center networks and internet architecture. They're two separate things, right? You would never in a million years ever deploy a campus LAN architecture in an internet provider. There's just way too much overlap. You would never do that. And if you are doing that, you're applying the wrong architecture. Internet service providers use rings. They don't use campus LAN design. If you are integrating certain things into your architecture, then you would have perimeter devices like edges that would interconnect your two architectures, but you're not going to mix them together. So I think that's the thing you need to realize is you're not injecting campus LAN into the internet provider. And I think that's where you're getting hung up. Based off the way you're asking these questions and trying to get clarification on stuff, that's what I would assume that you're trying to map. They're not done the same way. So whenever, for example, let me go back over to this topology here. When you look at something like this, if I was to ask you, set up, let me zoom in here just so it's easier for you guys to see. I want you to take ISP1 and I want you to get all these devices to talk to each other. I don't care how you do it, just make it happen. What would be the first thing you would do? I know you're not able to answer the question, but you would, one second. So since I know you can't answer the question while I'm asking it here in the video, and you're probably going to give me a text response in the comments, which is completely fine, here's what I would do. I don't care the IGP. Let's say EIGRP. Let's even go RIP version 2 because we can be special. Well, you deploy an IGP here in the core, you give each one of these devices its own /32 loopback, and then you advertise the transit links and the loopbacks into IGP, ISB, EIGRP, RIP. I don't care. Whatever IGP you want to use. And then once you do that, then you do a full mesh of peerings. 1 connects to 2, 3, and 4. 2 connects to 1, 2, and 3, and 4. 3 connects to 1, 2, and 4. 4 connects to 1, 2, and 3. You just do a full mesh of peerings. Guess what? You don't have to worry about anything else. Now, let's take a little zoom over to the right here a little bit. We have a route reflector here because part of the ENARSI topics, let's talk about route reflection. So as I was reading through this, like, oh, I need to have a route reflector in here. Guess what? Boom, problem solved. I have a route reflector. So what do? I do the exact same thing. I come in here, I do my IGP connectivity, I have my transit links and my loopbacks, and then I have my route reflector peer to all of my routers via iBGP. Now, I mentioned that I was going to rebuild my service provider BGP and multicast topology because I intentionally built it wrong, but then as I was going through, I was like, okay, this doesn't make a ton of sense because of the way the routing is going to work. You're not going to have this. I was trying to make it as real world as possible. So what you normally would do is you wouldn't have you wouldn't be using RFC 1918 address space. And so what I did was this. I did a trace route to Google from my house. Do you see any public or private IP addresses in that trace route? Well, yeah, Rob, I do, the first hop. Well, that first hop happens to be my gateway. That's my core switch in my home, the 3750X. That's my core. And then from that core, there's a default route that points to my firewall. My firewall from there goes out to the internet. So now, fortunately for me, my public IP address is not here because I intentionally turned that capability off on my ASA. So what ends up happening is you get a bunch of public IPs. That is how internet routing is going to work. So there's another question that asks, can I use, and I'm going to zip up here to the top because of the question. The question was from Alec. I was wondering if the links between routers inside ISP can have addresses from private range. No, they're not. In certain scenarios, they could. MPLS VPNs are kind of the exception because you're dealing with private networking. But more often than not, the provider is going to take, more than likely, is going to hide all of their infrastructure. Because in MPLS VPNs, one of the things you can do, and I might, actually, one second here. Let's look at like router 8. One of the things that you can do is no MPLS IP. There it goes, propagate TTL. Forwarded. This command right here, no MPLS IP propagate TTL forwarded. If you were to do this, what ends up happening is in the service provider core, you hide all of your addressing. So you don't get to see the end-to-end connectivity. So I would have to do this on all the CSRs in order for this to do the job that I wanted to do. But by doing this, you hide your infrastructure. Because no provider wants you to know their internal workings of how they have stuff built. They're going to protect themselves from attack and other stuff. So they're going to do the exact same thing. They're not going to allow the, whether it's private customers that are using MPLS for transit or internet reachability, they're not going to give you public IP address, or private IP addressing. You're not going to see RFC 1918 inside the service provider. So when we take a look at how this works, right here, they're going to have it set up very similar to this, where we do a range of addresses that are public, which is exactly what I'm going to do. I'm going to use like 1.12, like 1.x and 2.x over here, and I'm going to do redistribution and network statements so you guys can see what this looks like, so that when we do internet reachability, these routers are going to see the internal network connectivity. It's going to be all public addressing, because that's what the internet does. It's all public address space. So you can lab it up with private if you want, but it's going to give you a skewed look, because if you try to look on the public internet, you're not going to see private addresses. They're going to get dropped. The internet providers are expecting your edge. You're going to be natting from private to public. And then when traffic gets back to you from internal resources to be a NAT, you're going to translate from public to private. And that's the point of NAT. So, well, technically speaking, it's not, but anyway, that's what NAT does. So, hopefully that answers your question, and it kind of helps you understand the why, because it's like, I feel like I've been circling the drain with you on this one for a little while, and you're just having a really hard time grasping the concept, and that's fine if you are, but I want to be very clear when I say this type of stuff, because, it can get into the weeds rather quickly. So I can give you guys lots of examples on stuff, but when it comes to like eBGP route reflector routers, that's actually a very, very simple one to do. So instead of this guy right here would have eBGP to this guy, right? Well, what do? You don't make this guy your route reflector, you make this guy your route reflector. That's it. It's just moving just changes which router is doing the route reflector service, or that role. That's it. There's nothing more to it than that. So, depending on, when you get into MPLS VPNs, it changes things a little bit, because you have VPN route targets through your VRFs and things like that you need to take into consideration. But beyond those, you really don't need to worry about that too much. Are there good route reflector designs? Yeah, Google for them. They'll show you all kinds of good stuff that's out there. I mean, that's how I learned. So from what I understand from you, the Cisco documents and RFC are not compulsory to study, correct? No, they are. I would absolutely, compulsory, meaning mandatory. I would say if you're going to be taking an exam from Cisco, you should absolutely be reading documentation from Cisco and the RFCs, because the RFCs are what the documentation and the operating systems are configured to do based off the RFC. RFC, or request for comments, is how the IETF and the IEEE, when they're trying to come up with routing protocols and standard-based protocol operations and capabilities, that's how every vendor works. They all have to. Are the commands going to be the same? No, probably not, because you can't have competing competing syntaxes out there. That's why Cisco is Cisco and Juniper is Juniper. But you're absolutely going to want to read the documentation, because guess where all your exam questions are going to come from? Documentation. I mean, I remember specifically getting a test on Service Provider version 4 written exam, and I read through the question, and then I didn't know how to answer it. So then I Googled that question when I walked out of the exam room and I had my phone, I Googled it, and within 30 seconds I had the answer, because I just didn't read far enough in the BGP config guide. But I'd say 90-ish% of the exams that I've taken, everything comes out of the Cisco documentation. How do you deal with forgetting details of topics? It's very frustrating. It's like you have to revise everything you know almost daily, or you forcefully forget them. Because I do stuff like this. I build out topologies where it forces me to configure stuff to the point to where it's become muscle memory. How many times have I configured VLAN 10, configured a trunk link, configured a spanning tree root bridge, and a port channel? Tens of thousands of times. Because I had to. I wanted to become second nature. Like, I don't even have to, I don't have to go through and I just know what spanning tree is going to do, because I've been doing it so long. But it's just experience. That's what that one comes down to. So the more times you implement a topic, I mean, you get to a certain point where I get no satisfaction at all by configuring OSPF. I've done it so many times. I know exactly off the top of my head what I need to configure and where I need to configure it. Why? That's just how it is. But you do something so many times, you'll never ever forget how to do it. Take my CCIE away from me. I'm never going to forget how to configure OSPF or how to troubleshoot it. Doesn't matter. So it's one of those things you just do it over and over. Think of it like getting like an apprenticeship, right? You started as an apprentice, you spend X amount of time in the apprenticeship, and eventually you get to your journeyman. And then once you get to journeyman, you have to spend so much more time in order to get to master, and then you get your, however that works. All right, last two, maybe, I'll read the question, but I may or may not answer that now. Scenario question. If we have CE1 connected to, I think I know where this is going. If we have CE1 connected to the LAN, CE2, PE1. CE2 connected to the LAN, CE1, PE2. Okay. Each CE1 is connected to only one PE, meaning CE1 is not connected to PE2 and CE2 is not connected to PE1. Okay, I have to draw this out so that everybody can follow me at home. All right, so we'll try to read through this and try to answer it rather quickly. So we have PE1, we have PE2. We have CE1, we have CE2. These guys are connected like this. PEs are connected to the ISP core. CE1 connected to the LAN, CE2 connected to the LAN. So we'll say there's a LAN segment here. Doesn't matter if it's point to point or not, it's connected to it, so it's automatically a LAN segment. Now if I want to have a redundancy scenario, the traffic goes and is received from CE1 only, and if CE1 fails or PE1 fails, does traffic go to CE2? How can we do this BGP wise for incoming and outgoing traffic? This question confused me. I was asked this in an interview. Okay, so let's stop here. Let's pretend like the part B doesn't exist. So if I have this connectivity here, if CE1 fails and PE1 fails, does traffic go to CE2? How can we do this BGP wise? Well, simple. So let's assume that both devices get traffic equally, right? Well, if you want traffic to go via CE1, you can do this one way. Since you're the customer edge, I'm assuming you have control of the device. What you would do is on this peering, you would do BGP between the two via iBGP. The first thing I would do is I would set the local preference to 200 for the default route, right? So if you see the 0.0.0.0/0 in here, you're going to see with a 200 as a local preference, right? And then what you would do on this side here for going traffic outbound is you would set the AS path prepend. You would prepend, let's say, 65,000. You would do this times 2 or 3 outbound towards PE2. That would guarantee for traffic coming. Remember, AS path prepend is for traffic coming into the network, and local preferences for traffic leaving the network. That handles both directions. Hopefully that makes sense. So that's how you would do it that way. Let's go on to part 2. If we apply an HSRP on the CEs for the LAN traffic as the gateway, and the primary router fails, how would traffic shift to the backup router? What is the mechanism to cause the traffic to shift? I'm not sure what the answer they want is. Did they want me to say to set up 2 static routes and 1 backup, for example? No. So that's actually very, very simple. Let's assume down here that there's some sort of distribution switch, DS1, and you're connected like this. Well, everything's coming to this guy, but there's 2 egress CEs. What you would do here, you can keep the BGP configuration up here the same. So if PE1 fails, no big deal. Then that default route is lost. As soon as the default route is lost, then this will go away. Let me cross that out. This will go away. You'll no longer get the default route through CE1 from CE2. Or I should say on CE2 from CE1. And then traffic both internal and external, so leaving and coming, will go out CE2 towards PE2. If CE1 dies, no big deal. Then CE2 loses its default route from CE1, and then traffic goes out PE2. Fairly simple design. Now, if we advertise HSRP as a LAN gateway, so let's say we set this guy as the primary and this guy as the secondary. We're just setting a higher priority, 150, and let's say 100. Well, who's going to become CE1 is going to become your primary. Well, how do they keep track of each other? Well, there's using UDP port 1985 on the LAN segment. They're going to be sending traffic back and forth to each other. HSRP hellos are going to be sent back and forth. So what happens if CE1 stops sending a hello to CE2? Well, CE2 is not going to detect it for about 10 seconds or so, because you have 3-second hellos and then like a partial 1 second just to make sure timer. So let's assume 10 seconds goes by, CE2 doesn't hear anything from CE1 and declares it down. Well, then traffic goes over here. So then the priority becomes 100 and the VIP goes from CE1 to CE2. That's it. Spanning tree does a little bit of reconvergence here because now the uplink goes to a different device and Bob's your uncle. So that's how that would come into play. You don't need any static routes. This is irrelevant. Static routes aren't needed for this case because you automatically told me you're dealing with BGP because of the way that, can we do this BGP wise? Yes, you can. And that's exactly where I'm going with that. So you told me BGP, so BGP is up here. So you're always going to have this. So what I would do is, now, could you configure a static route? You could, but I wouldn't. I would do dynamic routing. Let's say for OSPF for the sake of argument. So I advertise both routes, and I do one with metric type 1, and this one over here with metric type 2. 1 is preferred. If 1 stops advertising, if CE1 loses its default route, we can't advertise a default route that we don't have. So then therefore this would get ripped away from distribution 1 and traffic would go towards CE2. So that's how I would handle that. Hopefully that makes sense, but that's how I would do it. And I've done that for lots and lots of customers. It's a very, very, very common failover design. If you're having a hard time with this, then you need to lab this specifically up and test the crap out of it. I actually did this for a customer. Like, I've done this probably at least 100 times for customers. A very, very common thing to do on the internet edge. And a lot of times you have you've got your distribution switch or some switch that's here. Then you have actually, I'm trying to think back. The last major customer we did this for, we did it like 6 different places. Same design. It was routers after firewalls. Yeah, so it was distribution switch. There was 2 of them actually. And then they had connectivity up to a pair of Palos, Palo 1, Palo 2. These guys were all routed like this. These guys had an HA heartbeat link between the 2. And then northbound of this was another set of switches. So this was, we'll just say edge switch, and this was actually a stack. So this one connected to one switch, this one connected to another one. And then northbound of that was a pair of routers, or we'll say edge router 1 and edge router 2. This guy was connected to this one. Each 2 switches in a stack. This connected to, so we got switch 1 and we have switch 2. They connected to like that. And then these guys connected to ISP 1 and this guy connected to ISP 2. I've deployed this lots of times, and we deployed HSRP between the 2, so traffic would be pinned to this guy all the time, every day. HSRP, and then it would only fail over to this guy if like IPSLA failed, we would fail over. I'm sorry, this was on the IPSLA was on the switch. So, and then HSRP was set up between ER1 and ER2. That's essentially what we ended up doing. So a very robust but redundant internet edge. So what you're trying to accomplish here is very, very easy to do. Most network engineers are going to know how to do this. Can you do it with static routes and a backup? You can. Just do a floater. You know, if I was going to do this with static routes, I would have a static route pointing from here to here. That would be the first static route that I would do. Actually, let me draw that. So you have PE1, you have PE2, you've got CE1, CE2, then you have distribution 1. You have your LAN segment setting up here. Can you do this with static routing? You can. Here's the caveat. You would need to create a couple static routes. You'd have a default route via static route pointing this way, and you'd have with a metric with an administrative distance of 1, and then you'd have another default route here configured to here with an administrative distance of 10. What you would do is you would end up taking an IPSLA, so you do IPSLA, and you'd ping quad 8, but you'd pin it with a /32 route, so you do 8.8.8.8/32, and you'd pin it to this IP address right there. You'd pin that, and then it would point to your CE1 internal interface, and which would guarantee that your IPSLA would point out this guy. So if something happened and your traffic went away, then you would be tracking this IP as well, right? So you'd have a administrative distance of 1. If something happened, again, it gets a little interesting when you start getting into it, because if you're if you have a static route that's not a floater pointed to this IP address right here, then you're having to be cognizant of the fact that if this IP address is still good, then your static route is still going to point this way, right? So that's why you need a tracker on this IP as well. It gets, like I said, and so you ping this, but you track, let's say 10.1.1.3 or whatever IP address you give it. You need to track that IP. So when you're tracking it, you track the internal. And like I said, this gets complicated. This is why static routing is not a good idea. This right here, that's why I canceled it right away. Static routing is not good in this scenario because you have too many variables to keep track of, which is why OSPF, EIGRP, you can do a default originate, specifically OSPF. I prefer OSPF over EIGRP for this. You do OSPF between these guys right here. If you're learning a default route through these guys via BGP, excuse me, then what you end up doing is, the BGP route is here and here. But you do a metric type of 1 here and a metric type of 2 here. So if the default route goes away here, then OSPF is not going to propagate it from CE1 down to the distribution switch. But he will propagate it via metric type 2 from CE2. So that's why I don't like doing the static route way, because it gets complicated, because then it's static, it's always there, and then you're having to do tracking and if not else statements. It's complicated. So I like to keep things easy because then there's no guesswork. Dynamic is dynamic for a reason. So that's the direction I would take with it, and then you can fail over with HSRP and all that type of stuff that goes along with that. So I'm not sure if you're talking about HSRP here or if you're talking about HSRP southbound. But either way, it can be done, but it gets complicated. So if you want to provide clarification for me, go ahead and do that. But that's one of those things where I highly suggest you lab this up if you haven't already done so. And if you can make it to a whiteboard Wednesday or a coaching session Friday session, I think you're overseas. I would recommend you do that, and then you can pop in and ask questions, and I can help answer those questions. Because sometimes it's a little hard to follow with your scenarios, but that's essentially where you would go. So that's what I would do. So I'm not saying it's always the right answer. Remember, there's 6 ways to get anything done in networking. So it's, the way you come up with may not be the best way, it might be identical to what they have today. I've done that too. It was like, I remember talking to a customer. I was interviewing with a customer a long time ago, and they asked me how similar this would work. And I said, and I whiteboarded it out. I said, this is what I would do. And they were like, I hadn't thought of that. Like, okay. And like, interesting. And then ironically, like a week later, they changed their design to do what I was doing because mine made more sense and mine was more scalable. But it's what I've been doing for years. But then again, I've been taught by some really smart guys. So that is why I have the opinion of it the way that I do, because it makes the most sense. All right, so we're at the hour-long mark. I didn't expect this one to take so long, but I'm glad it worked out. So I will work on other questions that you guys have coming along, and so yeah. Never thought you mentioned it. ISPs rather than internet. Rings. Yeah. So okay. So I'm not wrong. So you're, that's part of the thing is, there's no backbone. There is a backbone, but not in the traditional this type of backbone sense. There's no core in that regard. You have a bunch of rings like this guy. So you always have an alternative path anywhere in the network. That's how a lot of ISPs build their networks, because like I said, campus networking does not make sense in an internet provider core. So anyway, I will hopefully that answers your questions. If not, leave me a comment in the comment section below. All the appropriate links will be in the video or in the description. And then I'm looking forward to seeing all of you on Whiteboard Wednesday tomorrow evening at 7. Have a good one, everybody.